So here we have in the background the 175 and in the foreground the 130. And what I'm going to do is show you guys what I did to do a side-by-side setup with these two refractors from Astro Physics. Now, unless otherwise stated, everything, all the parts, everything is going to be from Astro Physics. And what you see here is little Moose. Moose! She's enjoying this beautiful spring day, and she is a big Astro Physics fan, so she wanted to make her presence known. But so what we're going to try to do here, and I'm going to show you the process of what I did, is to get these two refractors, okay, up on this mount, the 1600, with a side-by-side saddle in place, a 10-inch and a 16-inch, and I'm going to show you how I came up with a system to balance all this out. Little Moose, you going to say something for the video? She's just enjoying the sunshine. Okay, so let's start at the first thing we need to do. This is how I store my 1600 deck cap. So here we have the deck cap with the saddle in place. The saddle that I use is the 16-inch Easy Balance saddle. It is a Dove LM162 DOVE LM162. You'll note that the saddle is offset, the center of the saddle is offset from the center of the deck cap, and so when I use this saddle on the side-by-side dovetail, I offset it the same amount, so it's the same relative way that I'd be using it with the scope singly on the 1600 mount. In case you're interested in what I'm using here as the container to hold the deck cap and the saddle, when I store this for the 1600, I'm using a rigid 22-inch gear organizer. That's what it's called, and it's worked out great for this. So what I simply do is, for protection, I just fold this. I found this, I think, at Myers, just a large, kind of a something for yoga or some damn thing, I don't remember, but I bought it because it would work for this, and I just fold it over like that, bring this up over. This provides plenty protection. And it stores really well and protects it from getting damaged. So when I set up the mount the next time, I know exactly where to find it. If I'm traveling with it, I know it won't get damaged. Here we're going to take a look at what we're actually going to be using to do the side-by-side. And what you're going to have, starting here on the right side, is again another 16-inch Easy Balance saddle, the DOVE LM162. Over on the left side you have the 10-inch saddle. It is a DOVE DV10. So the 130 is going to sit here, the 175 over here. And as I said, on the deck cap, the 16-inch saddle is offset to the south, and I've done the same thing here. It's been offset using the same bolt holes. Now, to carry both these saddles, we are using the 18-inch side-by-side dovetail plate. That is an SBD18SS. Just in case you're wondering what bolts I used, for the 16-inch saddle, I used a 1 1/8 inch long, quarter 20 socket head cap bolts. And for the 10-inch saddle, I used 7/8 inch long quarter 20s socket head cap bolts. I want to show you something else that I did here. The 16-inch saddle, the bolt holes and everything are located in such that the place that you would set this down into, okay, this abuts the saddle perfectly. So that'll keep this parallel with this cut, with this machined line. But with the 10-inch, and I can see they probably, so that you could use anything anywhere and not have to have two of these, since this 10-inch is narrower and the bolts are the same, you could put this over here and vice versa. Problem is though, this being narrower, it doesn't line up, and I can't use this edge of the saddle against this back edge here, and bolts are not made for alignment purposes. You need like a dowel pin or something like that, a couple dowel pins for alignment purposes. So I came up with a way to ensure that this is parallel to the seat that it sets in here. So in theory, this and these, both saddles should be parallel to each other and perpendicular to the dovetail. So this is what I'm talking about. We're looking at the 10-inch here. You'll see that gap right up in here between, and you'll see where it's been cut out to be received on the dovetail. And you'll note over here on the 16-inch, it butts right up tight. What I simply did was get some feeler gauges that you would use for automotive use, for spark plugs, setting gaps, whatnot, and get them for about a whole set for $10. And I just kept switching back and forth, finding a combination that would fill that gap in between here. But you've got to be careful because you don't want to get so tight that this does not set down flat. This needs to set flat at the bottom here. So when you do this and you tighten it down, you have to make sure that this is setting absolutely flat. So here's the combination I came up with, okay? And I'm using the two thicker ones on each end and the thinner ones in the middle. But this is what I came up with. I've got a 4 thousandths, a 6 thousandths, a 22 thousandths, a 23 thousandths, and a 24 thousandths shim stock here, those feeler gauges. And so that's what I've used. So now this takes up the gap. This ensures that, in theory, this should be parallel then with this notched point here that it would receive into. So hopefully this is all parallel. And then I just tighten it down, and again, ensure that you want to make damn sure that down here it's sitting absolutely flat and that it's not kicked up like this. Because if you go too thick and you put these down, when you put this down, it's going to hang up because it's too thick, and it can only go so far because you're going to wedge these over a little bit, and then this is going to be up. So that's the combination I came up with. Let's take a quick look again. And hopefully if that focuses, I can't really tell here, that is absolutely flat. The first scope that I'm going to balance separately by themselves, I'm going to do each one separate, is the 130 on this 10-inch dovetail. So here's what my thought is. This is the center of where the telescope and the dovetail is going to sit right here. This is going to be the center of the center line of the telescope and of the dovetail, because it's going to get shifted over here a certain amount, because it's got to be smaller. It sets in, and then these clamps come in. So in any event, what I'm doing is putting the center of this, just eyeing it up approximately to the center of the deck shaft. So that would mimic, if this was bolted to the deck cap, then this would just be a simple matter of balancing it the way it would normally be by itself. And I'm not going to worry about the 16-inch saddle over here. I'm just going to bring it around, balance the scope, and I'll measure everything out, make note of those measurements of where, at some datum point on it, I'll make note, and the next time I set all this up, I'll just go to all those figures and I should be good to go. Okay guys, as it turned out, I had to remove the 16-inch saddle. So you'll see in here that that's been taken off. All I did was just lock down the axis, on the deck axis. I got it 90 degrees. I've got two 30-pound counterweights pushed all the way up on the deck axis, and then I just locked down the RA axis at 90 degrees, gave it a little bit of a snug, and that's holding it. And on the deck axis, I released the worm so that it's free floating, as you see here, and it stays pretty much put where I move it around. Okay, so here we're looking at it from what would be the east side of the mount, and again, the axis is the worm's been released, so it pretty much stays where I put it. Now to standardize this, here's what I'm going to do on both telescopes. The dew shield is going to be all the way out with the lens cap on. I'm going to have the draw tube all the way out, and then I'm just going to put a 90-degree prism. I've got various kinds of eyepieces, so I'm going to assume that this big ass mount, when you put a eyepiece in there and the worm's locked down and you got the axis tight, it isn't going to give a damn about that slight other imbalance. At least that's the way I'm going to look at it here. So the next thing I'm going to do is get some measurements, write them down, and the next time I set this up, we're good to go. Alright, I'm just going to show you. So again, it might be hard from perspective wise, but this is the center of the deck cap. Okay, and as I stated earlier, I've located the saddle and eyed it up in the approximate center of the deck cap. So now that puts the telescope in center line of all that. And so my thought is, let's balance that like we normally would. And hopefully I'll do the same to the other side. I'll take the 130 off, go do the 175, and then once the 175's on, then it's just a matter of, I'm not going to take that off. I put the 175 on first in the future, then put the 130 on with the measurements that I'll take. Alright, in this particular case, for this setup, the distance from the back side of the saddle, this is the eyepiece end, the focusing end, the distance from the Dove 10, the saddle, to the back side of the dovetail is 2 7/16 of an inch. Now something else I'm going to do is I'll also take measurements from where the rings are to a part on the tube, so if something ever gets taken down, I'll have everything back to original of what I'm doing here today. Also, want to apologize, we've got a little wind going today, not bad, but this camera picks it up easy. And the neighbor, he's doing some digging, so just the sounds of the country here. But it is a beautiful day. And by the way, I don't know if I mentioned, this is my first setup, so this is just something I had in my head, and we're just giving it a wing today. We're just trying it. Hopefully it all works. Since I had to take that 16-inch saddle off, I thought I'd show you. This is the edge. This surface has been machined down to receive saddles, and then this is that edge I was talking about here that the saddles butt up to. Okay guys, same thing here with the 16-inch saddle for the 175. Now with the 130 saddle plate, when I raised it up to the center line like I'm doing here to be an approximate center of the deck cap of the deck axis, I only had 2 clamps. Okay, I didn't worry about the one clamp that didn't go on because it's a lighter scope. This is the 175, so this bottom clamp isn't doing anything here. Okay, it's only the top 2 are clamping onto this. So what I'm doing is I've really snugged that down, and what I did is I've got this little cool 1/4-inch square drive Tecton ratchet, and then I just put an adapter on it, 1/4 to 3/8 with an extension on it, with the 3/16 Allen head socket. That way I can get in here and give it a little bit of extra torque, especially since the other bolt is on the back, is right here and it's hard to get into. So I want to give those an extra snug, being that it's only on the 2. Oh, one other thing, I neglected to show you this setup here from the south side of the mount. But there's the 2 30-pound counterweights that I've just stuck all the way up the deck shaft, and then just torqued down the locking knobs there for that axis, and haven't had any issues. It ain't going anywhere. Okay guys, here we have the 175 on. This was a bit more tedious. The way I did this is when I was able to put it level, like you see here, pretty much level, and it didn't dip forward or back, I called that good. Because now if I go up there and I tip it a little bit forward, it'll go down. If I go to the back and tip it a little bit, it'll go the other way. So this, I'm going to call this good right here. And with the 175 from the focusing end, the focuser end, we have from the dovetail plate of the 175 to the saddle plate on the mount is 1 7/8 inch. Okay, next thing I'm going to do before I put the scope on is up on the Dove 10 end. I'm going to put this stop where Astro Physics puts a hole in. This is a tapped hole. This is going to be a 1/4 20 by 1 3/4 inch long socket head cap screw. I've got a nylon bushing. It's a 1/2 inch OD, 1/4 inch ID. Then I'm going to put on 2 washers, because if I put it on like that without washers, this damn near will probably hit the saddle plate. So I'm just going to fur that out a little bit so that this doesn't touch. So here's what I'm talking about. And I neglected to say that nylon bushing is 1 inch long. Now I'm not sure whether I'm going to need it on the opposite end by the 175, because when I balance this, it may not go far enough down to actually be able to put that on. Okay guys, so my first mistake is I used a shorter counterweight shaft. So I got my neighbor Don over. He's going to help just kind of, I've got all the axes he's locked down. Going to have him just keep an eye on the telescope, hold that. I'm going to take those counterweights off. I added a 24-pounder to those 230s. I'm going to put the longer shaft on and see what happens. And then I got to balance out the 2 scopes longitudinally. Quite a pain in the ass. Okay guys, had my neighbor Don come over. Really appreciate your help, Don. I'll make sure you get on the list for a telescope from Astro Physics for all your help. But I'll make sure it's like a 40-year wait list first. Anyways, so what I ended up doing was getting it balanced on the right ascension axis. And then I had to tweak the deck axis with the 2 telescopes. Basically, once I got that laterally across, you know, side to side, to tweak it, I had to take the 175 Remember initially I said that from the focuser end of the dovetail to the saddle was 1 7/8. I ended up shifting it, ended up being 2 7/16. So 2 7/16, and then just sliding it, back and forth. So as you see it now, it is pretty damn well balanced when I remove the worm, release the worm from both axes. So to recap, I ended up having to take and put on the stock counterweight bar that came with the 1600. I had a shorter one on there, so I had to put the stock counterweight bar on, and the addition of a 24-pound counterweight with the 230s. So as you see it sitting there, it's balanced pretty damn well. Here's something else I'm seeing. That leg, you can see where it's sunk down into the ground with all this weight. Never had that happen before. Although probably just the ground seems dry at the top, but it's sunk in there, and it's sunk in just a little bit here, and it actually didn't sink in over here. But the leg over there, it sunk in pretty well. I'm going to get me some aluminum pads, quarter-inch aluminum that I can set on the ground and rough them up, and probably use that for the future here, because I've got clay ground. Well, that wind is really picking up, guys. Anyways, the million-dollar question I'm sure you're all asking yourselves is, how do the two line up? Well, I put a 18.2 millimeter D-light eyepiece, moving back and forth each one, and there is a shift. But if you were going to do some higher power on the, it's still in the same field of view, but it's shifted about, I'm going to say, a little more than a quarter. So if you've got something in the center on the big scope, on the 175, the 130 is shifted a bit, about a quarter the field of view. Not too bad. I'm not going to worry about it. I'm not going to get any kind of a thing to change that. I'm satisfied. If you're using a little higher powered eyepiece on 175 in a wide field, on the 130, you'll be fine. So I think I got it working pretty well. Other than the leg sinking, which I can take care of that. But other than that, it's working out really well. Pretty happy with it. Don't know that I'll do this very often. It's a lot of work. It's definitely a lot of work. But once I've got this set up and I took all the dimensions of the various points, it'll be real easy to set back up again. Here's that original stop that I put on the side of the 130, and on the other side where the 175 was, that hole wasn't visible. It was hidden by the saddle, but by the time I got it all balanced out, it worked out excellent, because now with everything balanced with the side-by-side, I'm able to put my other stop here, and so now I have safety stops on both ends of that dovetail plate. So if something were to loosen, which I got things cranked down, but I've got that extra added safety measure in there. Okay, the tripod, I mentioned that, is an ATS 12-inch. I'm going to do a go-to here, and we're going to check out the meter. I've got it set to 16.5 volts, and hit go-to. Deck axis stopped. Look how lazy Moose is. She didn't even help me set up today, and she's already pooped out. And it looks like little Moose is happy with this setup too, so say bye, Moose. She's not going to say much today.